So using if statements in C++. We'll talk about why we need conditionals for selection. I'll tell you when to use if versus switch. Basically use if when it reads better. And then we'll show you the syntax, and we will write the bulls and cows calculating thingamajig. So let's dive in and make it work. So I'm pretty excited right now because we're about to make our code actually do something useful. Before we carry on, thank you to those people who pointed out that according to the Unreal coding standards, I really should have called this bool cow count struct, f bool cow count, naming structs just like classes. So I'm going to go ahead and fix that now by highlighting, clicking Control R for refactor twice, and then putting an F prefix in front. That also helps us right here when we see f bool cow count, bool cow count it should be. So of course the actual name of the variable shouldn't change, so that was a slightly overzealous find and replace. Okay, let me recompile to prove that that works, and fantastic. All right, so now we need to make this algorithm actually work. So before we dive into the algorithm, let's go a little bit further and introduce you to an if statement, because you're going to need that in the algorithm, and then we will write the algorithm in pseudocode and then actually make it happen. So this is an if statement. It basically says if condition 1, here in brackets, then execute a bunch of statements. Optionally, optionally we have an else if with another condition and some statements. And optionally, although I suggest you always put it in, you have an else and some statements. If nothing else, excuse the pun, you should be putting else in so that this condition here that you think never should happen, well, that's the point you want to alert the developer that we should have never got here. All right, so basically you're going to be using if and else, and sometimes else if. Now, I should say that if you get to any more than a handful of statements like this, then we want to be going to something called a switch statement, which we'll see later. Basically, you use if statements when the conditions are slightly more complex than a switch statement, i.e. we may have different logic in condition 1 and condition 2, rather than just a value like, if it's 1, do this, if it's 2, do that, if it's 3, do the other. That seems like a switch statement. But if statements, if some logic, then do something, and if some other logic, do something else. That's set up for an if. So we're going to loop through all letters in the guess, and then we're going to compare against letters in the hidden word. And then if they match, then we're going to say increment bulls if they're in the same place, and increment cows if they're not. Okay, so let's make sure we're clear on that. We go through each letter of the word. So let's just write out the word ant, for example. And then let's imagine that we've guessed the word and. What do? We start with A here, and we go through A. Oh, they're the same, so that's a hit. And then we compare that A to an N, looking for cows, and there's no match. No match. Okay, then we move on to the N, and we compare it to the A. No match. Now there's a match, and it's in the same place, so that's a bull. And then the N to the D, no match. Okay, and then you do the same with the T. So that's the algorithm it's going through. Pretty simple. Now what we need to do is actually start writing the loops and the if statements. Now this is 4 levels of indentation. 1, 2, 3, and then the code that'll actually be inside here is the 4th. You could actually say, if they're in the same place, increment bulls, and this would be pseudocode that's even closer to the actual code. Can I spell increment? I think that's okay. And if not, or we could say else, increment cows. Now be careful of writing code in comments though. Okay, so stay away from code. This is okay here just about because it's still kind of English. So make sure the algorithm works in words like this, and then we go through and start fleshing it out. Now, let me do the first couple of bits of I'll do the outer loop for you, and then I'll ask you to do the rest, okay? Because I want to give you a couple of tips. For int32 is the name of the iterator. Now, you may be tempted, or you may have seen I. We're going to use I here, and I'm going to change it later, and I'm going to allow us to create a bug, so bear with me. You'll see I and J a lot, so I want to use it so you're exposed to it. So for I, starting at 0, let's go up to, but not including, the length of the hidden word. Now, we don't have the length of the hidden word at the moment. So right here, right above the loop, we need the things that we need to support the loop. So we have an int32, hidden word length, equals my hidden word. Now, it's a string, so when you hit dot and access its functions, you'll find that you have a length option. It's a method, so you need to call it with braces. So we're putting the result of looking at the hidden word's length into this variable, okay? So now we can say we want to go up to the hidden word length, but not including it. Now that's because when we're going to use this I, we're going to access the inside of a string, and they start counting at 0, remember. So this will go from 0 to 1 less than the hidden word length, which is exactly what we want. We'll see that in a minute. Then I'm going to put I++, which means increment I, and then I'm going to put my braces. Okay, although I'm going to put that second brace down the bottom here in the right place to start with. I'm doing this very slowly for now, as it's our first time with an if statement. So, and it's only our second time with a for statement. So there's our for loop. It's going to go round this, looping through all letters in the guess. Now what we want to do is compare that to the letters in the hidden word. So we're going to need another for statement. And what's quite common is that people start doing stuff like this. For j equals 0, because they use the next letter up, j is less than hidden word length, because we're going to compare all the letters to all the other letters. J++. Now, by the way, you might see ++j, and that works fine as well. There's a little bit of argument as to whether there's any performance difference. Frankly, at this stage, we don't care whether we increment before or after, because we're not returning the value. All right? So we don't want to worry about that optimization or performance now at all. You'll also sometimes see, rather than less than, you might say not equal to, and you might see that that is an optimization. But again, let's not worry about optimization right now. Let's worry about getting the code running. If later, when we do performance profiling, we find out there's a problem with the speed, we will fix it then.
Hi, Sam here, just with a quick edit to warn you about an error that you may be experiencing. If you enter a word which is shorter than your hidden word, then you're going to end up with your app crashing. Now, at this stage, just avoid entering a word that's shorter than your hidden word, because in a few lectures' time, we are going to be fixing this. In fact, the exact lecture in which we are going to fix it is called Writing Error Checking Code. So you can wait till that lecture and we will sort it out. But basically it comes down to us using the hidden word length in both of these loops. But you can wait until that lecture to see more exactly why.
Okay, so before handing it over to you to complete this pseudocode, I want to check a couple of things. Firstly, let's check our brackets match. I'm getting an error here. So the problem is, if we click on this bracket, you'll see that that's its matching bracket. Therefore, this guy here, if we scroll up, is matching the start of the definition of the function, which is why it thinks the function has finished there. So let's just sort that bracket out there. And then we have some outdenting to do, so that hopefully now it's clear that that goes with that. When you click on this one, it goes with that. All right, so that gets the flow of that right. Now also, we have to, in main CPP, actually output some of this stuff. So I, back in main CPP, under play game, we're going to submit a valid guess to the game, all right? So we can actually do that now. We can say bcgame.submitGuess, and we send the guess in as a string. Great. Now, we want to capture what comes back from that. So what is it that comes back from that? Well, it's an f bull cow count. Remember, we've changed the type to have a prefix f. Just call it bull cow count. Why not just call a thing? All right, so then we get it back. That's fantastic. So we submit a valid guess to the game and receive counts, and then we print the number of bulls and cows. So I'm going to get rid of this your guess was, because it's quite useless, and we're going to actually say cout, and then we're going to go, now we need standard on the cout, of course. Then we're going to go bulls equals, and then output bull cow count. Now the way we access the member is dot bulls. I'm going to go on to another line, just to keep things simple to read in the code, but without putting a new line on the end there. Put a space and then cows equals. Oh. And then put the cows on. And then I will now put an end line. Remember, we need the standard. Fantastic. There we go. Let's just run the code and make sure that it's going to run apart from, there you go. It's going to say bulls and cows equals 0, but your job is going to be to finish that. So let's put you into the challenge. This is the code I want you to write, and what I want you to do is finish, submit, guess, and test. Finish the function, test it works, and celebrate your coding ninja skills. Go ahead, have a go at that challenge on your own now. But before I leave you to it, I just want to point out that you are going to need a variable name for guess. So when we defined the function submit guess, we didn't put the word guess on the end, so therefore the f string coming in does not have a name. So let's add that name as part of the challenge. The other thing to say is, I know this is a little bit of a tough challenge. We've got if statements within loops, etc. So just take it slowly, take a read around about if statements and see if you can get it done. If you can't, don't beat yourself up. This challenge is a little bit hard for beginners at this stage in the course.
And this is Sam here just to give you another hint, just to push you through if you are a beginner that's struggling at this stage. And what I want to say is that when you are going to get a character from the guess, because you're going to want to compare character by character, here's how you do it. Here's the hint. For example, if you want to get the second character from the guess, you actually type guess, then the square bracket, open square bracket 1, and then close square bracket. That's because we start counting from 0 very often in programming, and that is definitely the case when trying to get things out of arrays or out of strings. So the first character will be 0, the second character will be 1, etc.
So welcome back. Let's get this working. So what do we mean by if they match? Well, we want to say something like, and I'm going to put all my braces in. There are better ways of matching braces, by the way. Just for now, for the beginners, I want to just get them to manually do it. There's plenty of ways of making blocks into braces simpler. We're going to do that now. So we're going to say if the guess at position I equals, remember equals, the hidden word, or in my case, my hidden word, at position I, then we're going to go and start to do some more conditionals. So, why is guess unidentified? Because when we wrote this declaration, this definition from the declaration, we never actually said what the variable name for fguess was going to be. So I'm going to call it guess, very simply. Now we have a handle to refer to that thing. There it is. Now, there is a deliberate error in this line, but don't deliberate on it too long. It may be fun if you write exactly what I've written, and then we will use the debugger in the next video to fix it. That's part of the point. Okay, so if they're in the same place, the way you say that is if I equals j. If the indices are the same, then we do something. What do? We just say we increment the bools. So bool cow count dot bools plus plus. Simple way of incrementing, and then we're going to say, and I can put that comment on the end, by the way, leave the comments with the code, and then else, no point in deleting the comments, so you may as well leave them there. They're proper scaffolding that stays in there. They're like those stitches that that dissolve. I can get rid of that, or don't dissolve in this case, and just stay in place. So then what we're going to do, if otherwise, then the characters have matched. 1 second, I've got an insert problem. The characters have matched, and then what we're doing is we're saying, well, they've matched and they're not in the same place, therefore it must be a cow. Okay? I'll say that. So if they're in the same place, increment the bills. We could even qualify here. No, this is the if they're in the same place. So let's take that, pop it on the end there, and then it reads quite well. All right, now this is as complex as you're ever going to get in any of your coding. That's a bold statement, but I don't want you ever indenting more than 4 levels like this. This is as much as you're ever going to need to hold in your mind. I'm showing you this more as an exercise. Let's just try this. Actually, let's start with a short word. I'm going to change my word from planet to say ant, and let's just try it. I think I've gone back onto overwrite. I have. Look down the bottom right, overwrite. If you're having that problem, remember to hit insert. Okay, let's try. So if I put and, what do I get? 2 bulls, which is correct, the A and the D, and 4 cows. That's wrong. If I put and, I get 3 bulls and 6 cows. Great. Perfect setup. We have a bug. So what are we going to do in the next video is find and squash that bug using the debugger. See you soon.